Hello, welcome to Algebra 1. We're going to do our third lesson on powers of monomials. Again, just kind of cranking up the problem complexity a little bit. And by the end of this, you should be pretty well versed in how to solve these kinds of problems. If you have, for instance, 3x cubed, and you're raising the whole thing to the power of 2, and then you add to it 2x squared, and raising the entire thing to the power of 3, how do you handle it? Well, you have to use order of operations. This addition is going to come dead last. So that always happens last. Inside the parentheses is highest priority, but there's nothing we can really do there. So the next thing we do is the exponents. We're going to apply the exponents here and the exponent here, and then later we'll do the addition. So what we're going to have is here 3 raised to the power of 2 times 3 raised to the power of 6, because this gets applied to the 3 and then this gets applied here and makes it 3 times 2 is 6. By the way, it's the same rule. This is applying here. This is 3 to the first power. 1 times 2 gives you 2, so it's the same rule. You're multiplying exponents all the time when you do this. And then you have plus, and then over here you have 3 getting applied to the 2, so 2 to the power of 3, and then x to the power of 6, because this 2 times 3 is giving you 6. So then, the first term here, what is 3 squared? 3 times 3 is 9, x to the 6th power. What is the second term here? What is 2 to the power of 3? That's 2 times 2 times 2. You should be able to convince yourself that's 8, again, to the power of 6. Now, we look at what we have and ask ourselves if we're done. Can we add these together? Well, since we've done this kind of stuff before, this is a like term with this. The same variable is present and the same exact exponent is present. If this were x to the third instead, then we wouldn't be able to add these. But since it's x to the 6, we can add them. And 9 plus 8 is 17, and we have to carry the x to the 6 along for the ride. And that's the final answer, 17x to the 6th. All right, now let's do something very, very similar for our next problem. We're going to basically reuse a lot of the same things, so we'll have 3x cubed, and we'll raise it to the power of 2. But instead of adding it, let's multiply by 2x squared raised to the power of 3. So let's see what the difference is. Here we added them together. Here let's multiply them together. So we can kind of reuse some of the same things that we had from before. We know that this first term comes out to 9x to the 6th, so we'll write it as 9x to the 6th power, and it'll be multiplied by 8x to the 6th power, because we are basically using the same result from before. We're doing all the distributing into the exponent, and these are the things that we get here. Now, what do we get? All right, when we're multiplying things together, we can add exponents if the bases are the same, or if it's a sort of a like term, for lack of a better word. So 8 times 9, you multiply the numbers, you get 72, and x, you add the exponent, 6 plus 6 is 12. And the reason I'm doing this problem is because it's really confusing at first when you add the exponents and kind of what do you do in the different cases. So in this case, we're multiplying everything together, and so because of that, when we multiply things together, we can add the exponents if the bases are the same. But when we're adding things together, we just look for like terms. We carry it on into the answer, but we're really just adding the numbers. That's all we're really doing. So if this confuses you, go back a few lessons. The last probably 10 lessons, we started talking about like terms and what to do in different cases, and so you may have to practice those skills. But these are the correct answers for these problems. All right, now, what if we have a couple of other similar problems? We'll kind of do them in pairs. What if we have a times negative a times b squared, all raised to the power of 3, plus 2a squared b cubed, all raised to the power of 2. And we want to fully simplify this. So we have to deal with the first set of the first term here, and then the second term here. Now the a is just kind of hanging out there. We'll do that later. We have to do the exponents first. So that's going to go in, and we're going to have exponents here, and then we'll do the same thing here, and then we'll kind of go down the road. So we're following our order of operations. Exponents is going to come first because inside of these parentheses there's nothing to really do. So we'll have an a, and inside here, this 3 is being applied in to the whole thing as a negative a. So the way to write it there, or you know what, another way to write it, another way to think about it is, this negative sign is really like negative 1. So the exponent of the 3 can be applied to the negative 1, cubing it, and then to the a, cubing it, and then to the b, making it b to the 6. Make sure you understand that. That's another way to think about it. This is really negative 1 out here, so you apply this to the negative 1, cubing it, then to the a, cubing it, and then when you get here, 3 times 2 gives you 6. That's probably a cleaner way to think about it. And then for the second term, you'll have 2 raised to the power of 2, and then a raised to the power of 4, and then b raised to the power of 3 times 2 is 6. And all we're doing here is distributing this in, multiplying exponents along the way. Now, let's take it one step at a time to get our answer. The a is going to remain on the outside. Inside here, what is negative 1 to the third power? It's negative 1 times negative 1 times negative 1. When you do the first two, negative 1 times negative 1 gives you positive 1. But then times another negative 1 means it becomes negative again. So you'll have negative a cubed b to the 6th plus, inside here, 2 squared is 4 times a to the 4th b to the 6th. Okay? Now before we can do this addition, we have to do any multiplication. Remember, multiplication comes before addition, and this is multiplied in here. So this is going to have to be multiplied by this term. So what's going to happen here whenever we multiply this in? This is a to the first power, and then we have a to the third power. Same base, we add the exponents. So the negative stays there. This will be a to the 4th power times b to the 6th. Okay, let me wrap this in parentheses just to make it clear. And then here it'll be 4a to the 4th, b to the 6th. Now look what happened. Now we have a to the 4th, b to the 6th, and here we have a to the 4th, b to the 6th. So in order to add monomials together, they have to be like terms. And the only way they're like terms is if all the variables match and all the exponents match. So because everything 100% matches, these are like terms, and I can add the numbers. This is negative 1 plus a positive 4. What's the answer? 3 times a to the 4th, b to the 6th. 3a to the 4th, b to the 6th. And that is the final answer. You got to be very careful with doing this stuff. There's a lot of ways to go wrong. Distributing the 3 in, you could have gotten something wrong here. Doing the cubing and the squaring could have done something wrong there. Multiplying the a times a cubed could have done something wrong there. And then adding them could have done something wrong there. So that's why you have to really be careful. Now our last problem here, well, it's not the last problem, but the problem that looks similar, I want to show you the difference. What if you had a times negative ab squared cubed, but instead of adding them together, let's multiply it times 2a squared b cubed squared. How would you handle that? Well, the only difference between this problem and this problem is we're just, instead of adding, we're multiplying it. So let's kind of use some of the previous work. We know that this term comes out to this, and we know that this term comes out to this. So let's kind of copy this down, and we're effectively going to be multiplying it. So it's going to be negative a to the 4th, b to the 6th, and we'll be multiplying it now by 4a to the 4th, b to the 6th. So when we're multiplying things, we just multiply the numbers. 4 times negative 1 gives us negative 4. And now we're multiplying a to the 4th times a to the 4th. So same base, we add the exponents, a to the 8th. And then here, b to the 6th times b to the 6th, same base. So it's going to be b to the 6th plus 6 is 12. So the answer is negative 4, a to the 8th, b to the 12th. You see that answer is obviously different than what we got before, so you got to be careful when you're adding or multiplying to know what to do. All right, we just got a couple of additional quick guys, and we'll call it a day for this lesson here and close this topic out. What if you have something you haven't seen before, too much anyway, x to the power of n raised to the power of 2. How do you handle that? See, before it's always been numbers, x cubed raised to the power of 2. You would multiply them, for instance. But here it's x to another variable raised to a power of 2. Well, the same thing applies. You multiply them. So really this is going to become x to the power of what? 2 times n, which we write as 2n. So don't let that frighten you. You still multiply them. You still write them as a multiplication. Everything's basically the same. Okay, what if you have a to the power of x times a to the power of 3? Same thing. When you're, don't get scared. If this was a 2, like a squared times a cubed, you would add them, right? Because it's the same base. 2 plus 3 would be 5. But here we don't know what x is, so we still need to add them. So you say a to the x plus 3. And this x plus 3 is in the exponent of a. I know it looks a little weird, but that is how you simplify it. That's the answer. And that's why I'm doing these, to kind of show you some weird things that you'll see and pop up every now and then. What if you have 2r to the nth power to the power of 3 multiplied by 3r to the nth power raised to the power of 2? How do you do that? So you do the same thing. You start off here, you distribute the 3 into the 2, and then into this, and you'll distribute this into this, and we'll go from there and simplify. So what you have is 2 to the power of 3, and then when this one goes in, you multiply. 3 times n is 3n. Okay, that's one term. And then the other term here, 3 goes in and applies to the 3, making it 3 cubed. And then this 3 goes into the n there, multiply them, making it r to the 3n. So now you go ahead and get your numbers squared away. And your numbers here, 2 to the power of 3 here, 2 times 2 times 2, is going to give you 8r to the 3n times 3 cubed. 3 times 3 times 3 is 27, r to the 3n. Now you have a bunch of stuff multiplied together. What is 8 times 27? 8 times 27. And when we do 8 times 27, we get 216. And then we're multiplying these together. Now the bases are the same, so we add the exponents. 3n plus 3n. So to make it clear, I'm going to write it as 3n plus 3n. And we write our final answer. It'll be 216r. What is 3n plus 3n? The same. You basically have two like terms here, so you can add them, and you get 6n. So the answer to this, even though it looks weird, is 216r to the power of 6n. All right, we've got one more here. What if we have 3x to the nth power squared times x squared raised to the nth power? Same thing, let's work with each term separately. The 2 is going to distribute to the 3 and to the x to the nth, so it'll be 3 squared x. What do you do here? You multiply. 2 times n is 2n, multiplied by, and then you have x squared to the nth. You multiply these guys, 2n, so x to the 2n. So what you have is 3 squared, 3 times 3 is 9, okay? And then you have the same base here, so they're multiplying these guys, so you add the exponents. So you have x to the 2n plus 2n. And you can simply add those, and that becomes 9x to the 4n, because those are like terms. And that's the final answer. So make sure you understand this. I know these last few problems were a little bit weird, but you are going to encounter some of these things as you get into algebra. But notice that even though they look a little weird, the rules were the same. They're always the same. Once you learn a few rules, they're the same. You distribute the 3n to everything, and you multiply exponents if you get there. It just so happens it comes out to 3n. And the same thing here. Whenever you're adding them together, for instance, we're multiplying these guys together, so we add the exponents. Well, we know that 2n plus 2n is 4n. So the same rules of algebra apply. It's just sometimes when you have something that looks slightly different, you have to have the confidence to know that you're doing the right thing. So practice these. Every problem here, practice them yourself and make sure you're getting the right answer. And then follow me on to the next lesson where we will continue teaching algebra step by step.